Hi everyone. Today we'll be exploring some data and we'll do some exploratory data analysis for a data set that we have. And the data set was given to us by a financial company, and it's for a second stage data analyst interview that I have with them. And now it will be quite interesting to see and how this moves on, as the stages of the interview of this data analysis we will do today will be on looking at the data, understand it first, explore it as much as we can. Then we move forward and we'll do some data analysis, data cleaning, and finally we'll do some data visualization. But then, most importantly, the reason we'll do data visualization because the aim of this data analysis is to make a presentation of 10 minutes and present it to stakeholders that do not really have a deep understanding of the data world. Now, the data that has been provided to me, it's not about financial data, but it's about an electricity market, about electricity market. Now, the reason they have provided me this data is because they want to see how I would analyze data in a different industry, and they want to see my sort of analysis skills. And so let's move forward. Today I have done some analysis already, and decided to start to record and want to share this with you. So I'm doing my analysis on Jupyter Notebook. Now, on my right, you can see the data set. We can see the market share data of each electric company. We can see the electricity switches. That means how many times people switch from one provider to the other. So it means between one providers like British Gas, EDF, and so on. Then we have the average tariff. So this is annual, as we can see, how much each household, let's say, spends with a provider, and this gives you an average tariff. And then we have the customer satisfaction, electricity and electricity methodology. And on the left we also have the dates. Now here on the left we have an explanation, a brief understanding of how the electricity market works and how our data set works. So we have customers, regulations, suppliers, tariffs, and so on, and how each thing works. Now this video will be quite long. It will be about how we explore data in a actual way. So we'll be going through exploring data as as a normal data analyst would, going through Google, Stack Overflow, and so on. Okay, so as I meant before, I already was doing some data analysis. So I have started by doing electricity market exploratory analysis of our electricity market. So I've marked down this. I've imported the libraries. I imported pandas, NumPy, Seaborn, and this is for visualization. Plotly for visualization again. Then Matplotlib for visualization. Now I've also used Plotly.offline, so it works on our Jupyter Notebook, and also offline. And I've imported this library. Now this is the first thing, of course, that we have to do when we do some data analysis, because we have to import libraries in our Jupyter Notebook. Now, next thing I've done, I've imported each sheet in a under the name, and I've assigned different names. So for example, we have market share, electricity switches, and so on, and they have all been imported in our Jupyter Notebook. Now, what I've decided to do is actually analyze and try to do some exploration on the first datasheet, which is market share, and try to understand the data. Now, here we can see data exploration. So what I have done is information on the data type and entries, and by this I just did market share.info, and it gives us some understanding on how the information is. So we have we can see that most of the information are floats, so numbers with decimal places, and we have date is an object. We have I just wanted to see how many missing variables we have, which is very important sometimes, because we can see that the data sometimes is missing, and might not be able to have good data to work with. Next, I have done describe. Describe is like it's very helpful, because especially when we have a lot of numbers, we can see the count. So how many numbers? So how many the count of each variable. So in each row, how many rows there are. Then we have the mean of the values that are there. So 23. So if we go back on British Gas, on our original data set here, we can see that it ranges from 25% to 20%, and now we can clearly see the 23.23480 means 23%.48, and it makes sense. So we have a standard variation of 0.015, and we have a minimum of 20. We can check this, and we can also see that maximum is 25. Perfect. Now, what I've decided to do, move forward, because we are trying to visualize data and give it a sense to people that do not understand data, let's say number-wise. So we're trying to visualize it by using a bar chart using Plotly. Now, we could have used Matplotlib, but Plotly is a bit more interactive and helps us to actually play with the data. Now, to clearly understand the market share data here, we can see it ranges from 1 to 0. I'm trying to understand how to change this. So as you know, we'll be doing data analysis and a lot of Google research here. But so 1 is 100% and 0 of course is 0%. But here we can already see each single supplier and how they have their market share. So in each quarter, for example, quarter 1, we know that British Gas has 25%. And at the very end, we know that British Gas has just 20%. Okay? So why? We can clearly start to understand. So this is bar chart. But what I've decided to do is to use area, slightly better. We can clearly see. Okay. So it's nice using Plotly because you can decide what to select. So let's say I decide not to see British Gas, I can remove it completely. But visually this is a bit more understandable because we can clearly remove whatever we don't want, but we can clearly see that British Gas is a steep decline, and we can see all this decline happening between all these power energy providers. Whereas here at the top we have small suppliers, which surprisingly starting from 2012, which they had a very small share of the market, it increased to a point that it took a very large chunk. So from we can small supply from being just 1%, it went all the way up to 9% of the whole market in less than 6 years. So it's great to see how much it affected our information. Now, what I decided to do next here, I was just playing with it. I was just trying to have a look. This is just I want to see some correlation on the market set. We don't really have much. See if we do market share, we don't have anything here. Market share, yeah, we could see for correlation here, but I don't think it's important because how is it correlated? I mean, of course they will be correlated, but I don't understand how we could derive any information out of it. Okay. Now, what we can start to look into here so we have a few questions which we can answer, and this is what they want us to answer, to be honest. So let's say questions to answer. You'll be expected to explain in detail how you analyze, visualize the data to answer relevant research questions. For example, the type of analysis that you carried out. For each type of analysis, the steps you undertook. Okay. How long it took you to complete the different steps, risks and issues that you encounter, how you address them. The data transformation, reshaping, if needed. Which tools, how you represent, okay. What are the main insights from your analysis? So that gives us some okay, so they don't want us to do much here, we just analyze a bit of the data and just simply to be able to understand it full on. Okay, now what we can do here, we see, let's move on from market share and we move to our next sheet, which is electricity switches. Okay, and we see the head. We can see that, so we have month, total electricity switches, both switching tariff and switching supply. Okay, so let me refresh myself on what switches are. Okay, so switching, a consumer is considered to make an electricity switch when they either change tariff or change supplier or both. Okay, so a tariff is so the standard tariff is a supplier's default tariff. It is variable tariff that can go up and down with the market. Okay, so what it means is that you have a fixed tariff, which is a contract that you have with your energy supplier, and once your contract ends, then you have the switch, which goes to the default tariff, which is a standard variable tariff, and that goes up and down with the market. Okay, and it says also that 70% of UK households are on standard variable tariff. Okay, so it's quite interesting information, I guess. Let's electricity switches. Okay, so from 2012. Okay, interesting. So this down total electricity switches, both suppliers, no switching supplier. Oh, I see. Quite interesting. Okay, so on the first column here, what we have here with date, of course. So let's start to analyze this data, which is quite interesting. So let's do this markdown. Markdown. Here we do electricity switches. So we differentiate this. Okay. Now we understand this. Now, I guess after here, what we can say is that let's do this. So month, of course, is data. Now, the first column is date. The second column here, we have both of total electricity switches. So that means switch from a tariff, from a fixed contract to a standard contract. So which is like not a standard contract. How did you call it? Into standard variable tariff. So from a fixed contract, so a fixed tariff to a standard tariff. And also we have data on. Okay, guys, sorry, I received the parcel and I just paused the video in the middle. Okay, so let's move forward and let's try to analyze the electricity switches. Now, a reminder of what is electricity switches. Here I made a silly mistake. Electricity. Okay. It's a reminder that if we see on our data set here, the first column is month, which are each month of from year 2012 to 2018. Then second row is total electricity switches, both switching tariffs and switching supplier. And then we have total electricity switches to different suppliers. Now, this is quite important because on the right, we have the switches to different suppliers. So that means, let's say, when a client or customer moves from British Gas to Scottish Power, npower, EDF, any other supplier. But then we also have switching tariff, which, if we remember from our explanation brief, so we can see that there's something called default tariff, which is the standard variable tariff, is a supplier's default tariff. And we also have something called fixed tariff, which is an offer that the supplier gives to the consumer as a guaranteed price for a fixed period of time. Now, the main difference is the one is a fixed contract with a fixed price of, let's say, £20 a month, whereas the standard variable tariff goes ups and down with the market. So let's say if the electricity market goes up or down, your tariff goes ups and down as is correlated to that to the market. And we can also see some good information here that approximately 70% of UK households are on the standard variable tariff, which is very interesting. And now also there's another piece of information that from fixed tariff, people will automatically be put onto the standard variable tariff unless they switch into a new tariff. Okay, so knowing this information, we can move forward and try to understand our electricity switches better. So I guess here what we can do, let's try to see electricity dot info. We can see that our date month is a date time format, and the other two are in integer format. Okay, and move forward here. So what we can do, because we have total electricity switches, both switching tariffs and switching suppliers, but we just have switches to different suppliers, I would like to create a new column which gives us just a column with the numbers of the customers that have switched tariff. So that would be electricity. So let's create a new variable called switch tariff equal to electricity. Okay, I need columns because I don't want to write down all the names here. So we write down and we'll get the columns names, columns, and we get these two. So we do this one first. Minus minus this. Okay, so it's pretty much we're just doing a simple subtraction here. We're doing the electricity switches. The total minus the totals the switch to different suppliers. So and that will give us the switch tariff. Oh, okay. So let's have a look. We have a result which is different than as you can see from our total and our electricity different suppliers here. So this is our switch tariff, and what we can do here now is just add it in our data frame. So here we create a new data frame, and we call it total electricity switches, not total tariff switches. That's how we call it, tariff switches. Okay, and that should gives us, and that should create a new column in our data frame, and we can now see it in our data frame here. Perfect. We have this. Now, what we can do now, we can start to visualize it, and I think it will be very important. I like to use the area. We can use both bar, I guess, but we can start to see, I think, px, which is our Plotly library, which we're applying. So I'm learning Plotly, so bear with me. So you'll probably go and look at Google many times. So px is our Plotly library. Here we apply the sort of graph that we want to use. So let's say we want to use bar, and then how was it? Okay. Okay, interesting. So what you're gonna do here? Market share, no. So market share is from the previous plot. On our X, we won't have date, but we'll have month because that's the name of the variable here. And in our Y axis, we won't have these because none of these are in the data frame. We instead have these. So let's go back to our column and we rerun this and we have all these names, which is perfect. And we just take them, we can just copy it, all of them here, and we can paste them. And so, this saves a lot of time, much faster. Okay, great. What we have left? Okay, we have total. Okay, I don't like random indentation. So how are we gonna label this? So of course we do X as state and Y as switches. That's how we're gonna call them. As simple as it is, switches. Okay, perfect. Anything else? No, we can run this and see what gives us unexpected UF well parsing. Where? Okay. Interesting. Why is that? Total electricity switches of switching tariff. Okay. Mm, mm, could be this. Nope. Completely not. Alright, so let's just take it slow. Maybe there's like an indentation that I don't see. You know what? Simple. We don't. If this is the case, we're just gonna take each single one, so we know that it's fine. Okay. So we have this first one, fantastic, and then we have a second one, and then we put our set total electricity switches. Now we know that there shouldn't be a problem. I don't know where was that parsing. Maybe you guys can tell me in the comments. I'm not sure. What's going on? Unexpected E or F? The fuck? How is that? Okay. Oh god, see. Input, blah 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 blah. Okay, let's try to just do one. Let's see what if that comes up. Okay, interesting. So nothing comes up. This is it, yeah? Okay. I see. So the problem is here. I think what happened here? Alright, alright, alright. Ah, see? This is what happened. I did not add all of it. See, let's go back. We can see it now. So let's re-add our columns. Okay, so do we have all three of them? Yes, we do. See, the parsing here happened because I did not finish um, the whole line. And you know, this is the problems I guess with like being a data analyst. These are the problems that you probably face most of the time. There you go. Now it's running. Perfect. Okay. Sorry. Okay. So we can see our three variables. Blue, total electricity switches, both switching tariffs and switching or says switching a supplier. Total electricity switches to different suppliers that comes within with the green one, and the red one is the different supplier. Sorry, so total electricity switches to different suppliers with the uh, with red one, and then the green one is the tariff switches, which is quite interesting to see. And so let's see the total, and we can clearly see this is the total. If we remove total and we just add total electricity switches to different suppliers, which means from a customer from British Gas into EDF or Scottish Gas or npower and so on. And we can clearly see from 2012, as it's going like it gradually goes up. So more people switch suppliers more often, whereas before, I guess, less switches. But that could be also the reason, as we saw before, that there are new the market share data, there are new providers, and we can clearly see that from 2012 to 2018, there were new small suppliers that were providing energy, and we can clearly see the rise of switches. So many people like to switch maybe for better deals and so on. Now, if we looked at total electricity tariff switches, it's important to remind yourself that, as it was said here earlier on, that switches happen when you move from a fixed contract into a standard fixed tariff. That means that your tariff goes ups and down with the market, but also when you switch, so a tariff switch. So when you change, when you switch, for example, from a certain contract to another. So from a fixed to default contract. and that approximately 70% of UK households are on standard variable tariff. Now, it's quite important to see because we can clearly see that the trends are different from the different suppliers. It doesn't gradually go up, so it's not increasing, but yes, a certain number of trends. We can clearly see that in November 2013 there is a spike, an outlier of 467,067 people, 667 people, and that was in November. And that I can assume that is because a large number of customers switched their tariffs into either a standard tariff, so from a fixed contract they went into a standard contract, or while I was paused, I was curious because I was looking at the energy thing. We can clearly see that. So if we go on November 2013, we can see that energy will rise by 37% in 3 years. And I guess due to this, people try to change contracts. So gas and electricity prices are rising at up to 8 times the rate of earnings. And I guess when this news came out, which was around November 2016, we can clearly see that people start to make switches because they didn't want to pay extra money for their tariffs. That could be one of the reasons. There could be many others. It's a switch of contracts. Maybe they switch suppliers, as we can see, and/or they switch suppliers, and that would mean that they will have a new contract, they will have a new tariff, and that could be the reason. And that could be because a new supplier came and played along. Let's see when our new small suppliers played a huge role here. So we can see in the fourth quarter some rise on some changes on our. Do we have anything here? No. On our fourth quarter, do we have any change? I mean, there is a bit of spike we can see here. Some extra layer. First utility played along. So I think maybe first utility took a good chunk of the market here. Maybe that could be a reason, but we don't know. We're just having a look through of the data at the moment. Now, moving forward, we can clearly see. Oh, someone knocked at the door very loudly. Okay, so let's go back. Sorry, someone else knocked at the door. And going back to our analysis of the electricity switches, we can see there are spikes throughout the years 2012 to 2018, and it's periodical. And they happen almost by the middle, so mid-year or by the end of the year. So we can see that, for example, here November, we can see here March, October, September, and March. Now, I assume these are contracts which are either ending, so from fixed terms they move into standard terms, and that will mean that the switch happens, but also because we can see there are a gradual switch of suppliers. So whenever someone decides to switch a contract, so from one supplier to another, it will then be automatically labeled as switching tariffs, because you're not only switching supplier, you're also switching a tariff because you are entering a new contract with a new supplier. And we can kind of assume this because, for example, in our variable total electricity switches, we have both switching tariffs and or switching supplier. So you can do both. Okay, so this is quite interesting to see. Now, having said that, we could probably start to look at other variables we could do here. So let's see if there's any sort of correlation. I mean, I don't expect anything here, to be honest, because okay. So total electricity switches 111. Okay. Of course, this is gonna be related. Yeah, of course, this is gonna be. I mean, the first row I'm not surprised because, of course, that's the total. And oh, what is this? Yeah, no, this pointless doesn't really show much, so it's not really helpful, is it? Okay, what we can do here, we could try to visualize in a different way. Maybe, we could try to have a look. Let's go on Plotly. No, I should have it saved somewhere of data analytics. Um, no, let's go on Plotly, guys. Plotly. Okay. Is it recording? Yes, still recording. Okay. So, scatter, line, area, bar, funnel, timeline. Okay, let's do timeline. This is interesting. Maybe we can find something. So, px.timeline dot timeline argument. So, I assume there are no x's. What does it say? Unexpected keyword. Okay, I'd assume that would work. Let's try something different. Maybe we could try with scatter. See, for me, it's just nice to be able to kind of try new things. Maybe it doesn't make sense, but sometimes if we're able to visualize it, it helps us. Okay, so pretty much scatter graph gives us the same graph as before. I'd say less detailed because they're just points, extreme points. So let's say you can clearly see, but not very good. Doesn't help us a lot. We could do area as before. Actually, area is quite good, to be honest. I like it. I like it a lot. As I think it's a time series, we can see that it's just moving forward. We have a huge spike here. Okay, you can clearly see. Okay, so this is a total. Okay, and they get added on top of one another. But of course, if we remove total, okay, no, I don't like the either. To be honest, not good. Bar funnel. Could be funnel a good one? I never used it. Let me see. What kind of... Ooh, tricky. Let's see this. Okay. Interesting. Okay. Ooh, this is actually quite good, yeah. So the blue one is the total and is a reflection of the combined switches of suppliers and tariffs. So it's quite nice to see it. It's just there's a reflection of one another, but it gives you the whole thing. That's cool. Yeah, I like it. I do like it. I don't know if I will be able to explain it very well though. It's not very simple to understand, I guess. But it's quite nice, I guess. Funnel. Um, timeline. Looks a bit boring to be honest, but still try. Why is it not working? Start. Nah, it's long. Part of all. Plotly is very nice because you can do a lot of things with this. I think we'll stick with the bar chart actually because it's the best. Oh, area. Okay. Let me try here, funnel. So I'm just playing with different. Ah, this is good to be honest. I like this. It's better than the other one because it gives us some extra info and it's pretty much similar to this. So we could remove this one to be honest, and we can just remain with this one, and we're able to play with this quite well. Okay, timeline, scatter. Okay. Now, what we can do now? We've seen the scribe, we've seen the analysis, We have all the information that we need. Any other insights that we could find out of here? I don't think so. So let's start to move forward and let's have a look of the other one now. Which was not electricity switches. We move forward towards average tariffs. Okay, so here now it's quite interesting. We'll be starting looking into the tariffs itself, so the prices. So I reckon we can find some good prices. Average tariffs. Top. We're gonna go with this one. Pointless. Okay. So what are we gonna do? Average. We can see it. Okay. 5 columns. So date. Date. Average standard variable tariff. 6. Average standard variable tariff. Other suppliers. Okay. So we have the 6 large. 6. The cheapest tariff. Okay. Okay. So this gives us the average standard variable. So the average, and this gives us the cheapest. So okay. So let's visualize this. The average standard of other suppliers. Okay, so we can see the 6 largest one are the cheapest because of course they can compete with prices, and then we have actually no, it's not the cheapest. The cheapest tariff is all suppliers. Okay. Okay. Cheapest tariff, all suppliers. What would that mean? Let me have a look. So source 3 is the average standard variable and cheapest tariff annual cost in pounds by company type. Okay. So tariffs. Okay, we know. Regulation. Okay. So let's try to summarize this. So of course we have info. Let's have a look here. The sort of information. So date is our date time, date format, and the rest are in floats because of course there are numbers, decimal places. Now when we see this, we can see that date is on the left, first column. Then we have average standard variable tariff, and is average price, annual cost of each customer for the 6 large suppliers. If we look at the third column, we see that the average standard variable tariff from other suppliers and the cost for the customers is this much, so it's the average cost. Whereas we see the cheapest tariff from the same time period from the 6 large suppliers is 457. So this is the cheapest, and this is the cheapest tariff for all suppliers. I assume this is all other suppliers. Yeah, not just all suppliers. So it would make sense because if this is the 6th cheapest, so all other suppliers, I assume that's a mistake there. Okay, because it would make sense. Okay, so how are we gonna move forward? We know average tariff, dot info. We know the type. Let's do this. Describe. Okay. So we can count 80. So I assume there are no missing variables, and we can see this. Dot is no. Dot count. No. Sum. How do we do that? Oh, makes sense. I'm missing 2 parentheses here. Okay, so there are no missing variables in our data set with average tariffs. But let's just analyze this. So we have count of 80. So we were right, there were no missing variables. The mean is 546 between average standard variable tariff and from the 6 large suppliers. the average standard variable tariff from other suppliers is 531, so we can assume that this is cheaper. So let's make a note. So average standard variable tariff from other suppliers is cheaper. Okay, cheaper is cheaper, and we can see that also, and also the cheapest tariff is cost, also the cost, also the cheapest tariff is from all other suppliers. Okay, so this would make sense. So tariff from our average, in average, from our period of time from 2012 to 2018 is cheaper if you went with other suppliers instead of the 6 largest ones. Yes, you might have smaller bills, cheaper bills in certain periods of times. So like certain months or certain months, certain quarters, but in others would be much higher. So, but in average, you'd be better off going with the average standard variable tariff. Now, so standard deviation here, 2024. So the minimum, we can clearly see that here is cheaper. Okay, so the cheapest tariff here is the same. Interesting. This is very interesting actually. 25%. Okay, this is cheaper. Okay, now go. Okay, no, see, so my assumption on all suppliers, meaning that cheapest tariff is the lowest, is the other suppliers, makes sense because then the maximum as cheapest tariff is 407, whereas the cheapest tariff is 6 large suppliers is 516. So we can see again that yes, we are better off going with other suppliers in that period of time rather than the 6 large suppliers. And it's quite nice because we can see that how much money probably is probably involved. And we could even make like a simple formula and see how much they probably you could have probably saved. So I assume that here we can do so in average. So let's do an average. So if we went for saved money, so let's make a new saved money. So let's say we make our 6 large suppliers. So we go average tariff equal to, let's bring the column down. No, not this one. The next one. Opala. One. We want to cancel this one. Okay. Perfect. And we want average tariffs dot columns. We have the names now, and simple as it comes, we can do average tariff, 6 large suppliers minus, because we do not have any other. Okay, no, there's a mistake here. Okay, we don't have any missing values. We can confidently assume that this will give us a good number. And okay, yeah, that doesn't make sense. We have to do this. Now it makes sense. Okay, so and we skip forward, saved money. Okay, so how do you do average? Pandas average is mean, right? This is a copy of the thing I've done before. Okay, so okay, that's quite interesting to see. So a small insight, I guess. So in average, you'd probably save £14. So in the period of 2012 to 2018, in average, you would be better off with all the suppliers as okay, interpreted you would be better off with other supplier. As in average, you would save £14. Yeah, so £14 and 16p. Actually, that's quite a nice number we have there. You know, £14, 16p. So this is one. So with this nice understanding, so how much you probably save in average. And okay, we have some information here. Now we can move forward and let's try to visualize it. I have not done any data cleaning because you don't really need it here, but just for me to. So what we can do, we can just do px again. I can use matplotlib, but I'm trying to learn how to use, as I've mentioned before, after I'm learning how to use plotly, as it's quite interesting. I guess we can use again date, because we have a date format, but this is like a date. We would be removing these. Okay. We want to see. I don't want to do. I don't want. Okay, we can just label two of them now. Let's do the column here. Okay. Okay. We can do bar. There's no bar. There's line. Sorry. Dates, and here it is average tariff. And here is tariff. Okay. What does it say? Value of x is not the name of the column in data frame. Okay, makes sense. See? We were making different call. Okay. Interesting. What's going on? No, we can see the price, fluctuation of our average standard variable of the 6 large suppliers. We just let's add all of them. Let's see. Not all of them. Let's see the other one. So we have benchmark of comparison. Okay, so we can clearly see that yes, although in 2014 you had a spike, you'd be still better off for a large amount with your other suppliers because it will be much cheaper. And we saw before that it will be like £14 cheaper. So it's a great analysis here we can do. Okay. And let's try to visualize also the cheapest tariffs because as we're here we can tell. Okay, that's not what we want to do. God. Okay. Did I make a mistake? It could have been, but and I probably have taken the other comma. Should I have? Okay. Is this it? Yeah, that works. Perfect. Fantastic. Oh, what happened here? Interesting. So we have a very nice visualization here. We can see that from the month of what happened? From the month of June 2013 to December 2013, all other suppliers had a fantastic deal as it kinda like it was like kind of fixed rate, and it stayed the same throughout like 4 to 5 months. So the thing is great. Here we see that in both instances, the cheapest tariff was both given by the six largest suppliers and all other suppliers. So it's quite nice, to visualize this and understand it. And I reckon I will go with this graphs. Is quite nice, you can clearly see cheapest. So let's change the name for these. Average tariff. Average. Sorry, guys. And we had cheapest. Okay. We've changed the name for both. Let's try to a bar. Could bar do the job? Could bar do the job? Let me save this actually as save as FCA final. Okay. Let me have a look. Line. Let's see how it looks. No, I prefer that one. Much better. Okay. Gives us a good volume. Here, this is quite cool, so I'll probably stick with this, but just have a look. Nah, doesn't really represent anything. So quite interesting. Yeah. Okay, let's have a look. Funnel. Very bad area. Interesting, but not really. I prefer that one. Easier to understand. And that would go bar. Yeah. Bar doesn't really represent us anything. Okay, so we'll stick with line. Very simple, easy to understand, and I like it. It's quite simplistic. Sometimes the best way to go with something is just go with a simple bar. Okay. I think we kind of analyzed our tariffs pretty much. We have information, we understand what's cheapest, we see the insights, we can tell them that for this month to that month the rates stay the same. Cheapest, we can tell that between April to March 2016 to June 2016, we can clearly see that we had the same cheapest tariff between both of them. So I guess there could be competition, or because the market was just beneficial for both of them to give those prices. But then the prices of energy went up, and the six suppliers had to raise their prices. And we can see that it went down again. But then we had a huge spike back in January 2017. And what it says, so December 2016 on the peak here, and January 2017. So we're doing quite well, of course. If we went with other suppliers. What else are we gonna do now? EDA. So let's have a look of EDA. Python. What else does it suggest us to do? Blah blah blah. Data cleaning, bivariate analysis. Ooh, look at that. Static cleaning, correct format, headers, anomalies, outliers. Ooh, look at that. So much info. Okay, let me see. Our data was pretty much quite clean, so we didn't have to fixing rows and columns. Delete summary rows and columns in the dataset. Summary row. Okay. And we did some cleaning, I guess. Yeah, so missing values, missing complete at random. Okay, we have this, dropping the missing variables. We don't really need to do that. Okay. So how to fix missing values? Let's see how to handle outliers in the dataset. Univariate outliers are the data points whose values lie beyond. Okay, so we have all others outliers. There are two types of outliers. The univariate outliers. Univariate outliers are the data points whose values lie beyond the range of unexpected values based on one variable. Okay, so like randomness, like wow, what's going on? And we could say that this could be an outlier. Like what happened here? Like is 600 people boom switched out of nowhere? We don't know. Uh, the switch tariff, that could be an outlier. So that could be an anomaly. Or we have multivariate outliers. While plotting data, some values of one variable may not lie beyond the expected range, but when you plot the data with some other value, this value may lie far from the expected value. Okay, so while plotting data, some values of one variable may not lie beyond the expected range, but when you plot the data with some other variables, these values may lie far beyond. Okay, so far away from our range that would be expected to see. Okay, so after the understanding of the cause of we can handle them by dropping those records or putting them to values or leaving them as easiest, if it makes more sense. Okay, I mean, I can understand what he's trying to say. So we either remove them, we keep them as is. Uh, mhm. Okay, if we analyze data by taking two variables, comes into consideration one data, it's known as bivariate analysis. So scatter plot, pair plot. Okay, so he's just doing analysis which we have done before. Pretty much it's the same that we have done for using plotly. Same pretty much. He's plotting a scatter graph. We don't need a scatter graph, I guess. No, we could look into it if you want. Let's say scatter. Yeah, ugly. Perfect. Well, there's correlation matrix. A correlation matrix could be used, just to see. And we could do this actually, heat map. Okay. But what's he gonna give us? Nothing here, I guess. Wow, boring. Okay. Data, and that's our. Sorry, maybe it's getting dark. Let me wear my glasses. Okay, perfect. We can try to see what's going on here now. Have I imported Seaborn? I think I have. Okay, so yeah, total electricity. Well, we have to. We can average tariff. See, getting confused. What is PLT? What the hell? Let's remove this. Okay, cool. So we have. If it's on a variable tariff, of course. I mean, we can make an assumption here again that we can tell that, okay, if prices of the largest 6 suppliers are going up, there's the likelihood of the other suppliers going up as well. And that's not the case. We can see that in this month they were very competitive, and the prices were just and prices kept going up there. I don't know how they managed. I reckon there must be some mistake here, or some missing values, or it could be just like they were in loss all this period. I don't know. Something crazy must have been going on. So cheapest tariff. Right. I don't really like this, so no, we'll skip this. Yeah. So we don't have any categorical value. We can plot some categorical. Well, we can plot using our candle, but it's not good. Okay, now with the yeah. I mean, it's pretty much doing what we're doing anyway. So quite similar. Okay, this is my matplotlib um, cheat sheet. Let's call it like this. I don't use this much. I don't want to use this at the moment, is because I want to use Plotly for the visualization itself, so it helps. But you know, this is a great one. Let me just, I think I have them saved anyway, so it's not a big deal. Okay, so let's move forward and let's try to look at the last one. So okay, let's remove this one. It's called customer satisfaction. Customer satisfaction dot. Hi guys, sorry again. I got interrupted. Let's move forward and proceed with our analysis again. So we're looking at customer satisfaction, and let's make a markdown here now. We can make a markdown and divide this. So we will do customer. Nope. What did I do here? Customer satisfaction. Okay, and we'll be analyzing this sort of data. Okay, let's go forward. So what we're gonna do, let's look at the data first and see. So we do customer satisfaction dot. Shall we do the info? Let's do info. So we get some information. Okay, so we know that there are 24 entries. It's usually 23. 0 to 23, and electricity has just 20 entry, and electricity new methodology has 4. Okay, so the rest are empty. Now this gives us some good information, to be honest. So no, let's do describe later. Let's have a look first at our head. Okay, we can see that there are missing values. It said 24 before, right? So let's do 24 top. 24. Okay. See, it's quite interesting because we have 3 columns. Quarter ending, which kind of tells us the ends of the quarters, and the end of the date. The format of the date is not the same, so it's quite important. So we might have to convert the date, and we have to learn how to do this because I'm not very good at converting dates. So we'll do this together. Then we have electricity. I guess electricity means the values are of course satisfactions, as we have seen before. These is satisfaction level, so it kind of increases, we could see. And I bet the electricity is because the other column, electricity new methodology. I believe that electricity is the traditional way of electricity. So BP, British, sorry, what's that? What's the name of that? So yeah, British Gas, EDF, all these big companies. And the last column, which is electricity new methodology, is the new methodology of gas. So I guess new companies that are popping up, and they seem to have quite a high rate of satisfaction. Okay, now we know this. Let's move forward. And customer satisfaction. What it says? Head? No. We can do info, maybe. Yeah. No, let's describe actually, as we did before. Okay. Customer. So count. Okay, electricity. So it doesn't describe, does not include quarter ending because of course it kind of recognizes that it's an object, so so it doesn't include in the describe function. Electricity has 20 entry and new methodology is 4, and we can kind of tell that the average customer satisfaction is higher with the new methodology compared to the electricity of mean. This traditional electricity, we can also tell that the maximum satisfaction is 73 and the minimum is 49. Okay, but then again, it would be hard to compare the both right next to one another because one has less entries than the other. So I'd say because it would be kind of biased at this point to and say that electricity methodology is better than the traditional electricity because of how little information we have. Okay, so anyway, let's try move forward. Let's try to change the date. Actually, let's work with the date. So how do we do this? Object. No, so yeah. So object today. Okay, look, we already have it because we already looked into it in the past. It's very important for us to understand this, of course. Converting object to datetime format in Python. Okay. So below is the datetime object. Okay. So item frame in there. Would that work? Datetime. Is this a library? Let's have a look if this is a library. Might have to import this. Okay, looks like it is, yeah. Library. Because I don't have this installed on my PC, so we already went here, so. Okay, there you go. This helps us. So we're just gonna do, what's the name? Conversion of date from object to date, datetime. Okay, format. All right. So we kind of know what's happening. All right. So we just gonna run this. Okay, it runs through. Perfect. And now, because let's have a look of what's happening if what happens if we do this on our data set. Okay, so it's quarter ending. pd.datetime custom satisfaction. That work? Let's see. It doesn't work. Data frame has no attribute to datetime. Data frame has no attribute to date. Okay, why? Interesting. What does he say is that? Okay. Not a method on data frame. Try. Okay. What does it do here? To tweets df time equal to. Oh, I see. I see. Okay. Makes sense. It makes. What does this? Makes sense. Yes. 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 So because. Okay, what happened here? This is a PD. Now it should work. Oh no. Day is out of range for month. Day is out of range for month. So anyway, the error that we had before was because I called it within my timesheet, within my sheet, like the data set I was working with, but it's not a library. So the error is not because I didn't have the library or anything else. It's just because it was a pandas. Um, it was from a pandas library, so it was a function from pandas, and this is why because I used a different. I was calling it from a different function, which was my customer satisfaction sheet, and didn't make sense for Python, and Python couldn't find what's going on. Okay, now we know what's happening and we can work with this. But now we're having another problem. Days out of range for month. What is going on? Okay. See, everything about on Python is all about, like, you make a problem, you find a solution, then another problem arises, and then you have to find that solution. Okay, okay. So maybe help at perfect. True. Okay. Interesting. More universal is use parameter format with arrows equal co-errors for replacing values with other format to none. If format is standard, okay, add only co-errors, errors, co-errors. Okay. Okay. Let's try to do this. Let's try to change the format. So we're working with the format here. Okay. Oh, I have something in my eye. I don't know. Okay, so it's quite important here to do this. So format, comma, and our, how did we look? So we have year, month, and year, month, and year, month, and day. Okay, sorry, I have to pause this for a second. Had some interruptions. So I realized the camera was off, but while I was working through, I managed to convert the data, and the way I've done it is just choose the data which was not formatted in a correct way, let's call it like this, and then just use a lambda function to apply this on all those dates which were not in the correct format. This is the only way I could find. At least it took me some time to be able to format every single, because I couldn't format the whole column because it was keep throwing an error as every time I was going through. Whenever I arrived at this point, our function throws us an error, so I decided to do this in a separate, with separate variables. So now we have this, okay, and so let's have a look. Customer satisfaction. Okay, so we have a nice date. But it's still, the type shows that it's still an object, so we can try to change this now into a to-date format. And how would that be? Okay, to-date time df. Okay, let's try it. PD dr. Okay. So this is the way. Was that quarter? Did that work? That did not work. Day is out of range for month. To daytime. What does this mean? Okay. If a day does not meet the time limitation, passing error, ignore. Okay, so we have to show the format. Would this work? Maybe. Would this work? Maybe. Okay. So we have first. There you go. We have first date and then year. Unmatched. Okay. I don't know why. Still throws time that does not match format date. So we're having an issue here that we're not able to match our data. Oh, I hate this. Okay. Is our month 3, 12, 12? Our month seems to be fine, right? But you know what? It's too. We're not able to do that. Listen, it's gonna be too, it's taking too long. So what we're gonna do now? We're gonna try to still work with these, because now at least we have a cleaner date. We can do here. We can do. Let's try to plot this now. That should give us the date. Sorry, here we'll be doing customer satisfaction. Okay. Quarter ending. And at the y variable, we'll be using something nice. Okay. Top. Customer satisfaction, we'll be using electricity. Okay, let's try to do this. Customer satisfaction dot column, so we got the names of the columns in the correct format, I guess. Yeah, that's it. Let's try to run this and see if it works. Okay, it works, perfect. Now, labels quarter ending. Quarter ending. And customer satisfaction. Satisfaction. Okay, perfect. Nice. So we can play with this now. Interesting. Can we play this with something else? I wonder. Maybe a pie chart? Pie chart wouldn't do the job. Let's see what we can do here. For no timeline, scatter. No, scatter wouldn't. Line. Maybe line. Okay, now it doesn't work because we have our customer satisfaction, which is different. I mean, we can already compare it, I guess, because due to the missing values. Now, we could do an average, but you know, because this is customer satisfaction, and 4 inputs are not enough, I guess. What we can do, bar line area scatter. No, doesn't. Okay. But I completely think that this is quite good, you know, because it kind of tells us how we can easily differentiate our 2 different type of methodology, and it helps us to understand how the customer satisfaction is different from one another. So in the blue one, of course, we have the traditional electricity, whereas in the red one we have the new methodology of electricity, which is quite great. Yes. I don't understand, why don't I have the word electrocomplex network? I don't know. All right, fair enough. Do I have any other bar charts? Don't. Okay. Hardest part was formatting the data in a in a common and even. Hardest part was formatting the data in a common and even in a even formatting the data. Okay, so the hardest part was formatting the date. So the hardest part was formatting the date, as it had different formatting. Okay, so it makes sense. And I think that was a challenge. So we can say this tomorrow, and also we can find the insights out of this is that the blue shows the periodically the customer satisfaction over the period of time from 31st 03. So from the from March 2012 to December 2016. Hardest part was formatting the date, as it had different formatting. Challenge. Is this how you spell challenge? Sorry guys, there you go. I am Italian after all, so please, I will make mistakes quite a lot. Blue shows the customer satisfaction over the period of time from March 2012 to December 2016. Okay, fair enough. And I'm thinking what can be done here. Red shows the customer satisfaction from March 2017 to December 2017. Okay, now this is quite important to understand because we cannot compare, although the data for electricity so here I just forgot for electricity. Okay, for electricity new methodology. Date for electricity. Although the data for electricity are not the same, do not have the same number of inputs, we can say that electricity new methodology has a higher satisfaction level. Okay. So now we can, I think we can kind of say that we are kind of finished our with our analysis. You know, in a very simplistic way, we just visualize them. We try to work with the data. We could have cleaned the data, but you know, if we clean the data, for example, if we remove the missing variables here, what would have happened? We don't know. Well, if we remove them, what would have happened is that, so if we remove these with a function on Python, it remove also this column. Now, the reason there are no values here is because probably there are not the electricity new methodology was not in the market yet, so that's why it's empty. However, here it's kind of worrisome. What's happening here? I guess this is caused by some kind of missing values. So anyway, total electricity, tariffs, market share data. Okay. So 3, 6. So let's assume these are the top 6 ones. The rest have almost little customer satisfaction. I mean, I guess these ones are the one that we will be looking into it, the data that has the red customer satisfaction. No, they have entries, so they have entered the market in 2012, but 0% was theirs. And moving forward, they had very little growth. But by 2018, kind of peaked at 9% for small suppliers, but for the remaining companies, remained from top 3% to 1%. And I assume because they have managed to get such a small portion of the market, they haven't received many customer satisfactions ratings, at least throughout those periods of time. Now, that could be a reason. Okay. That's it. And pretty much, I guess this is our exploratory analysis, and I hope that it makes sense to you guys as much as it makes sense to me. I was kind of all over the place, and I'm sorry because it's my first time trying to speak and analyze to a camera, and I'll try to do more analysis in the future. And I hope some of you likes this video, and if you want me to do more in the future, please let me know. And also, please let me know how you'd probably face this challenge and how you'd analyze the data. I apologize because I stopped many times because I live at home, so many interruptions. But beside that, yes, this is how I've analyzed my data, and thanks.